Alright, if you want rock hard abs, no, abs, we're going to talk about absolute modulus function in this video. Absolute modulus function for VCE math methods. Oh yeah, cool stuff. Mitchie, I know you need this. You have a SAC next week. It's late March now, almost late March, and you need to know this kind of stuff. Absolute modulus. Okay, so as you probably know, absolute modulus, what we're talking about are the goalposts. These things, right? So what does that do, right? It's, think of it this way. It's like positive thinking. Because what happens? Everything turns positive. So if you had a function like absolute x, right? Originally the function looks like this. That's a crap drawing, okay? It goes through the middle. But what does it do? It bounces back up because now everything is positive. That's what the absolute modulus function does. Now this disappears, it goes back up. Okay, so that's the primary function of the modulus function. But when it gets, mixed up with all the other things like transformations, that's when it gets a little woo. So let's look at one of those. Just keep in mind, everything is now positive inside the goalposts, inside the absolute function. Boom! Alright, so let's say we have something like this. 2x plus 8. Alright, so now, what kind of graph is this? What kind of graph is it? Linear graph, you got it. So how do we draw that normally? Well, we go, okay, there's a y-intercept at 8. How do you find the y-intercept, by the way? Make x 0. When? Always. Always when? Always. So make x 0, you get 8. Gradient is 2. I'm sure you know this. I'm sure you know this. Linear graph, boom. Where's the x-intercept? Neg 4, right? So we know this. Now, we're going to absolute the whole thing. Boom, what happens? It bounces back up because everything inside the absolute must be what? Must be what? Positive, right? Positive. What? Positive. So it goes back up like that. That's it. That's all there is. Everything inside the absolute stays positive. Now, and by the way, I should say also, 0 stays as 0. So instead of saying everything's positive, now it's positive and 0 because the range includes 0. It goes from 0 up to infinity, right? That's the range. And the domain is everything, still. So that is exactly how you absolute a function like this. But it gets a little bit more complex when I go minus 4. What does that do to the graph? Now, if you know your transformations, you know exactly what to do. But if you don't know your transformations, maybe I'll make another video on this, but transformations are like the holy grail of math methods. If you don't know your transformations, go home and eat some bacon, okay? Know your transformations. So negative 4, by the way, is this inside or outside the absolute? Outside, right? So if it's outside, does that mean the graph can go below 0? Yes. Yes. So let's say we've drawn this and now there's a negative 4 on the end. What happens to that? Well, what is that? It's a translation down, right? It's 4 down. So now it looks like this. Does that make sense? So it looks like that. Where is this point? Well, it was a negative 4. Now it's at negative 4 again because of that. Where's the thingamajig, the y-intercept? Where is that? Well, it was an 8. Now it's 4 down, so it's at 4. Does that make sense? It's not that hard. It's not that hard. Now, x-intercepts. How do you find the x-intercepts? Well, we can count, but how do you normally find the x-intercepts? Think about it. How do you normally find the x-intercepts? What was that? What? Y equals 0, right? So let's do this. Let's do this. This is another important thing about the absolute function that you need to know. Okay? So we're talking about the x and y intercepts. Now, let's say I got y equals blah, 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 blah. Okay, this is important. Take notes on this. Take notes on this. I'm going to write it down here. Whenever you have an absolute function, you can divide that, you can split that into 2 different functions. One absolutely positive and the other one absolutely negative. So there are 2 functions, and I want you to do this especially when you have to solve for a particular solution, for example, like the x-intercepts, or some other solution that you need to find. So, the 2 different equations, one's absolutely positive, one's absolutely negative, and what that means is whatever is inside the absolute function is now absolute positive or absolute negative. So one of them becomes absolute positive, I'm going to use brackets, because brackets are cool, unless you use them wrong. 2x plus 8 bracket minus 4. So everything is positive. The next one, it's going to be negative, completely negative. So I'm going to do this. I'm going to go bracket negative bracket 2x plus 8 bracket minus 4. Now I use two sets of brackets because I know there's plenty of newbies out there who go, oh my god, I'm going to get confused with other brackets and where does a negative belong? And by the way, out of all the years of tutoring, all the years of teaching hundreds of kids, one of the biggest mistakes I've found over the years is that people screw up on the negatives. Like that little thing, right? I mean, you can screw up on the big things, but don't screw up on the little things. Okay, so we have an absolute positive 2x plus 8, and we have an absolute negative 2x plus 8. Now, I could have written that as expand the brackets and negative 2x minus 8. Oh, slow down, fella. Well, minus 2x minus 8, take out the negative, that's exactly the same, right? Minus 4, again, you can simplify that to negative 2x minus 12. Does that make sense? So that is one of the equations. Okay, right there. I should use a different color. Thanks for reminding me. That's why I got this thing. Alright, red. Red is hot. So, here's my arrow. That's one of the equations. The other one is obviously this, which turns into 2x plus 4. Right? Now, which one is which? Obviously, by looking at the graph, there's two portions. One is absolutely positive, one is absolutely negative. Well, think about it. I mean, this is easy because it's a linear graph. So you got positive gradient 2x, it's obviously that portion, and you got negative 2x as the negative gradient, obviously that portion. Simple enough? So always divide into two portions whenever you have to solve something, but to draw the graph, you gotta know your transformations. You gotta know your transformations. You gotta know your transformations. Like, seriously though, on a serious note, whenever I start with a new student, I don't tutor anymore, but whenever I used to start with a new student, especially in year 11, year 12, even year 10 sometimes, the first thing I always go through with them is transformations. Yes, that's right, Dr. T. Yes, Dr. T. Dilations, translation, dilation, nah, doctor, yes, dilation, reflection, and translations, all right? Those three are the most important things. You've got to know inside and outside, and that, inside, right, left and right, outside, towards the sky, up and down, right? That's important. Okay. Whew. I need some water. Alright, so that's how you draw it, and then you can easily find the x-intercepts through these two different functions. Does that make good sense? I hope so. Alright, so that is the basic type of absolute function kind of question that you're going to get. Okay, things that revolve around transformations and just solving for x, y intercepts and that particular pointy point. Now, I'm going to give you another question that isn't so much related to linear function. How long is this video? It doesn't say. Trying to keep it under 15 minutes just in case YouTube doesn't like me so much. Alright, so I'll give you another example. Let's say I'm going to use this side of the board. F of x equals to, let's say we're going to have something crazy, a parabola. Oh, slow down. Alright, so we're going to have, let's say, x plus 2 bracket squared minus 5. Alright, so what does that look like? Well, you say, okay, where's the turning point? This is in turning point form. Obviously, you know that from last year and the year before. Turning point form, negative 2, negative 5. Negative 2 is here. 2 and negative 5 right there. Okay, how would you find the y-intercept? Make x 0. When? Always, always when? Always. So, to draw this, okay, I mean, it most likely will be out here. If you really want to know, okay, find the x, y-intercepts. Find, make x 0. 0 plus 2, 2 squared, 4 minus 5 is negative 1. Okay, so there we go. So this is the graph right there. Absolute the whole thing now. Shouldn't be too hard. Boom. That's what happens. The bottom is gone. It's gone. Doesn't exist. It no longer is there. It vanished. Okay, so it looks like that. Now, what do we know about this? Well, we know a lot of things. We know that, well, that was real bad. It should come down here. No, it should not come down here.